So today we're going to finish up section 6, and today we're going to solve rational and absolute value equations. So just like before when we did this in the prerequisite chapter, you need to first find the LCD, multiply each term by it to cancel out the denominator. And also remember you need to check for extraneous roots, meaning you have to check to see if your answer is going to make the denominator equal 0. So let's try the first example. So my common denominator here, if I add, or my LCD here, if I add a 1 under this x, notice my LCD is going to be the 4 and the x plus 1. So what I'm going to be doing is multiplying my entire equation by 4 times x plus 1. Now remember, what we're trying to do is clear the denominator. So when I distribute it first to this one, notice the 4 will cancel, or the only thing it's missing is the x plus 1. So I'm going to be multiplying the numerator, x plus 1 times 4x plus 3. The next term is negative 2x. It's only missing the 4. And then the last term is missing everything. So I got to multiply 4 times x plus 1. So now what I need to do is FOIL the first part, distribute or multiply the second part, and then distribute the last part. This is stuff we already did in the prerequisite chapter. So I'm going to FOIL, and I get 4x squared plus 3x plus 4x plus 3. The middle, I'm just going to multiply the negative 2x and the 4. The right side, I'm going to distribute. And now I'm going to combine like terms over here. So I can combine the 3x, the 4x, and the negative 8. So then I'm left with x squared. And then when I add these, I get negative x plus 3 equals 4x squared plus 4x. Now I need to move the 4x squared over and the 4x over and see what I get. So let's go ahead, and when I try to combine my 4x squareds together, notice they cancel. And let me come on over here. So now I'm left with negative x plus 3 equals 4x. I'm going to go ahead and add the x. I get 3 equals 5x. Divide by 5, and x equals 3/5. Now, the only check I need to do here is see if when I plug this in to this denominator, will this make this a 0? No, it will not. So this answer checks. It's good to go. If you wanted to plug it into the whole thing to make sure that the two sides are equal, you can do that. But really, the only check I need to see here is to see if this solution is extraneous. Next one, same thing. I need to find the LCD, and then I'm going to multiply my entire equation by that LCD. So my LCD is going to be x minus 4. The only one that's missing it is the last term. So I'm going to multiply all 3 by x minus 4. So distribute it here, it cancels. Distribute it here, it cancels. But the last one needs it. So now I'm going to distribute. Combine my like terms. I get 4x minus 12. And now I need to move my x's together. So I can move the 4 over. I end up with negative 3x equals negative 12. Let me move it out of here. Divide by negative 3. And x equals 4. Remember, we need to check. Soon as I plug it in up here, 4 minus 4 is 0. This is extraneous. I need to get rid of it. So this answer is no solution, because this answer is extraneous. So get rid of it. Everybody good there? Let's try number 3. Now remember, when you're looking for the LCD, you should always factor the denominator first. So I'm going to factor this into x minus 2, x plus 2. So that's my common denominator. So x minus 2, x plus 2, and I need to distribute that to everything. I'm just rewriting because it's kind of cramped up there. And I can leave that like that. Just know that it's really the x minus 2, x plus 2. So when I distribute it to the first one, this one's missing the x plus 2. So I'm going to multiply 3 times x plus 2. The next one, when I distribute it here, it's missing the x minus 2. And then the last one already has everything it needs when I distribute it here. All right, so now I'm going to distribute and combine like terms. 3x plus 6 plus x minus 2 equals 12. So I'll combine my x's, I get 4x. Combine my constants, I get 4. I'm going to move the 4. 4x equals 8. Divide by 4. And x equals 2. Again, I got to check. Soon as I plug it in up here, 2 minus 2 is 0. It makes this denominator 0. So this answer is also no solution. Let's try the next one. Same thing. We're factoring first, finding the common denominator. If we don't factor first, we're going to be left with a really ugly problem that we're going to have to simplify. And it may get kind of really messy to simplify. So it's better if you factor first, because sometimes it's got part of the LCD hiding in it. So I'm going to factor this into x plus 2 and x minus 1. This one, difference of 2 squares, x plus 1, x minus 1. And then this last one, I'm going to factor out a GCF of 2. And then I'm left with this, which I can then factor, and it becomes x plus 2, x plus 1. Now remember, your LCD has to represent everything. So far I'm going to include x plus 2 and x minus 1. I've already got the x minus 1. So I don't have to repeat that, but I need to add in the x plus 1 to it. And then for the last one, I've already got the x plus 2, the x plus 1. Only thing I need to add to the LCD is the 2. So this is my LCD, this long thing here. Remember, this thing needs to get multiplied to all 3 pieces here. So let me go ahead and rewrite everything here. So I have 3 over, and I'm going to put the factored form just so it's easier. And then I could make this like a -1 up here, do a key flip change. And then x plus 1, x minus 1, and then equals 7 over 2, x plus 2, x plus 1. So now, once we do this, we need to distribute this to this one. Notice what it's missing is, this one's missing the 2, and it's also missing the x plus 1. So that's what's going to get multiplied to the first one. So it's going to be 3 times 2 times x plus 1 for the first term. Then the next one, I'm going to see what it's missing, and the next one is missing the 2. It's also missing the x plus 2. So when I multiply 2 times -1, it'll just be, let's do that, plus -2 times x plus 2. Then the last one, it's only missing the x minus 1. So 7 times x minus 1. So now I'll multiply. So 3 times 2 is 6. So I could actually change this to a 6, and then I'll distribute the 6. So 6x plus 6. Then here I'm going to distribute the -2. So -2x minus 4. And then distribute the 7. And now I'm going to start to combine my like terms. So I can combine this 6x and this -2x. This becomes 4x. And then the 6 and the 4 becomes a 2. Just rewrite that right side. And now start putting my like terms together. Move the 7x. You could also move the 4. It doesn't matter. Move the 2. -3x equals -9. Divide by -3. And x equals +3. Notice no matter where I put it up there, it's not going to make any of my denominators 0. So x equals 3 is a good answer. Let's try number 5. Again, I need to factor before I start. So let's go to 5. I'm going to factor this denominator here first. I can factor out a GCF of x. So now it's easy to see my LCD is this. This one's got the x part of it. This has the x plus 1. So x, oops, I don't want to highlight. So x times x plus 1. This is what I'm going to distribute to the whole problem. And if you wanted to show this as the factored form, you can. So notice when I distribute it here, the only thing it's missing is the x. So that's what I'm going to multiply to the 4x plus 3. The middle one, when I distribute it here, it's missing the x plus 1. And then the last one has everything it needs. All right, so let's distribute. I get 4x squared plus 3x. Then the red one becomes 2x plus 2 equals 1. Combine these like terms, and I also need to move the 1 over. So 4x squared plus 5x plus 1 equals 0. I now have a trinomial that I can factor. So factors of 4, it's either 4 and 1 or 2 and 2. I'm just going to guess and test. You could also factor by grouping here, but since it's the factors of 1, it's just 1 and 1. So I'm going to try 4 and 1, and it actually works. Set each of your factors equal to 0. Subtract 1. X equals 4x equals -1. Divide by 4. X equals -1/4. Subtract 1. X equals -1. Now I need to go back and see if any of these will make my denominator a 0. And notice when I plug in x equals -1 into here or here, it makes that 0. So that one's out of there. Negative 1/4 doesn't make anything 0. So negative 1/4 is the good answer. So only one extraneous. Number 6, same thing, multiply by the LCD. This will be the last one we do here, and then we'll move on to absolute value. So my LCD is actually 2x minus 3, 2x minus 3. It's the 2x minus 3 squared. So the first one is missing the whole thing. So I need to do 6 times 2x minus 3, 2x minus 3. The middle one is missing just one of them. And the last one has everything it needs. Now, when we go to do this, you can either, if you know the pattern for the binomial squared, do that first and then distribute the 6. Or you could distribute the 6 to just one of them, not both. Either way. I'm actually going to go ahead and do the binomial squared first because I know the pattern. It ends up being 4x squared minus 12x plus 9. And then I can distribute it and get 24x squared minus 72x plus 54. Right side, I got to distribute the 7. Combine the 21, the negative 21 and the 3. And now I need to work on getting my like terms together. So I'm going to move the 14x over and the 18. So now this is 0. 24x squared minus 86x plus 72. I got to factor this thing. I always look for a GCF first. My GCF is 2. Divide everything by 2. And now this one would get kind of large if you do factor by grouping, but you can. You could also, probably guessing and testing might take it long as well because 36 has a lot of factors. This actually factors, I'm just going to tell you what it factors into. You can go back and redo it by grouping or however you want. This will factor into the factors of 12 I'm going to use are 3 and 4. And my factors of 36 that I'm going to use are going to be 4 and 9. Again, whatever technique you want to use for factoring. And they're both negative to get the positive 36 and to get the negative 43 in the middle. Now, remember, we need to take each one of these factors, set them equal to 0, including the GCF. But notice whenever it's a constant equals 0, nothing comes out of that. If there were an x, we would have an x equals 0 as one of our answers. So 3x minus 4 is set equal to 0. 4x minus 9 is set equal to 0. I'm going to add 4. 3x equals 4. Divide by 3. X equals 4/3. 4x equals 9. Divide by 4. And x equals 9 over 4. Neither of these will make it won't make the 2x minus 3 a 0. So these are good answers. They both check. You could plug it in. 2 times 4/3 minus 3. This will give you 8/3 minus 3. Obviously, you're going to see it does not give you a 0 there. And then 2 times 9/4. Simplify. 9/2 minus 3. This doesn't give you a 0 as well. So they're both good answers. Now let's do the absolute value equations. So for absolute value equations, the first thing we need to do, and this is super important, and it's not written here, you have to isolate the absolute value first. Then you're going to move the bars, and then you're going to set the equations equal to the original and the opposite sign of the original. all solutions must be checked. Special case, remember, absolute value can never equal a negative number. So, for example, when you do absolute value, let's say I said, what could x be if we want this answer to be a 3? We know x could have either been positive 3 to get a positive 3 out, or it could have been negative 3. So x could either be positive 3 or a negative 3. This is why we're going to make our two problems. However, if you ever, after you isolate the absolute value, if it ever equals a negative number, stop and say no solution. Because remember, you will never, ever have it equal a negative number. So don't try to make the two problems. So let's try some examples. So for the first one, step 1, remember, isolate first. It's already isolated. So now what I do is I make my two cases or my two problems. I drop the bars. I set 1 equal to just how it is without the bars. And then the second case I'm going to solve is I'm going to set it equal to the opposite sign. And now I solve my two simple problems. Subtract 1, divide by 2. My first potential answer is x equals 2. Remember, we got to go back and check. 2x equals negative 6. Divide by 2. And x equals negative 3. So let's plug them back in and let's see if they work. So take the original, 2 times 2 plus 1, and it's in bars. And then here, plug in the negative 3. So 4 plus 1. 4 plus 1 is 5. Absolute value of 5 is 5. This one checks. So this is a good answer so far. Over here, negative 6 plus 1. Negative 6 plus 1 is negative 5. The absolute value of negative 5 is positive 5. This one also checks. So both negative 3 and positive 2 are good answers. The next one, number 8. Remember that special case. My absolute value is isolated. What will come out of this will never, ever be a negative number. Stop, say no solution. Because no matter what x is, it's never going to make what's in here become a negative number. Because absolute value always makes it positive. Okay? This will never equal a negative number. Let's try another one. Now, just a little side note before I do the last two examples. Let's say it's something like this. Let's say it's x plus 1, and we didn't really do any of these yet. Let's say it's x plus 1 minus 5 equals negative 1. Remember, step number 1 is to isolate this thing. So what I need to do is move this 5 that's not in the bars to the other side. At first glance, you might think, wait a minute, it's equaling a negative number. I can't do this. But once you isolate it, now what is in the bars equals a positive number. And we can solve this. The biggest mistake my Algebra 1 classes used to make is they would forget to isolate. They would look at that original, what I wrote in red, and say, wait, it equals a negative. I'm going to stop and say no solution. Isolate first. If you don't isolate, you're going to get the wrong answers. So then now that it's isolated, make your two problems, and then you would solve them. X equals 3. X equals negative 5. And now we would do the check. So if I take my original, 3 plus 1 minus 5 equals negative 1. 3 plus 1 is 4. Absolute value that, it's positive 4. Negative 1 equals negative 1. That one works. That's a good answer. And now do the same thing here. Negative 5 plus 1 equals negative 1. Negative 4 minus 5. Positive 4. And again, this one works as well. So these are two good answers. Pretty good? 2 examples and we're done. All right, here we go. All right, so we have, it's isolated. So we're going to drop the bars, but remember, when we set up our second case, we need to change both of these signs to opposite. So let's go ahead and set up our 2 problems. So the first one is going to just be the x squared minus 3x equals the way it is. The second problem that you're going to create, drop the bars, but flip the signs on both of these. So this will end up becoming positive 4x minus 6. And now you solve, we're going to get 2 quadratic equations that we have to solve. So set it equal to 0. I'm going to add the 4x, subtract the 6, and I get x squared plus x minus 6 equals 0. Factors in negative 6, that give me positive 1. That'll be positive 3 and negative 2. Set each equal to 0. Subtract 3. X equals negative 3 is the first one. Add 2. X equals positive 2. Now, I'm going to go back and do the check in a minute. Let me solve the other one. I actually have to do 4 different checks here. So I'm going to subtract the 4x and add the 6. So x squared minus 7x plus 6 equals 0. Factors of positive 6 that give me negative 7 are going to be negative 1 and negative 6. Set each one equal to 0. Add the 1. X equals 1. X equals 6. I now need to plug them in. Let me go up above and plug them in because I sort of ran out of room. I'll do it on the top. So I'm going to plug in first the negative 3, and I'm plugging it into the original. So I'm going to plug in, I wonder if black will come out better. So negative 3 squared minus 3 times negative 3, and that's in absolute value bars, equals negative 4 times negative 3 plus 6. So 9 plus 9. This becomes 12 plus 6. 9 plus 9 is 18. 12 plus 6 is 18. 18 equals 18. That one checks. So x equals negative 3 is good. Try the positive 2. So again, into the original. So 2 squared minus 3 times 2 in absolute value equals negative 4 times 2 plus 6. So 4 minus 6, negative 8 plus 6, negative 2, but I absolute value that negative 2. So this one does not work because 2 does not equal negative 2. So this answer is out. So far I only have negative 3 as a solution. I got to plug in the 1 and the 6 as well. So 1 squared minus 3 times 1 equals negative 4 times 1 plus 6. 1 minus 3, negative 4 plus 6, negative 2 positive 2. Absolute value of negative 2 is positive 2. This one checks. And then the last one, let's plug in 6. 6 squared minus 3 times 6 in bars equals negative 4 times 6 plus 6. 36 minus 18, negative 24 plus 6. 18, negative 18. 18 does not equal negative 18, so this answer is out. So the only answers here are x equals negative 3 and x equals 1. One more. Pretty good. Okay, here we go. Same thing. It's already isolated. Make your two problems. So x squared plus 4x, just drop the bars. The second problem, flip the signs on both. Get your like terms together. So I'm going to subtract the 7x and the 18. X squared minus 3x minus 18 equals 0. You can do the same thing over here. Let's just get it into the quadratic form that we need. X squared plus 11x plus 18. All right, so I need to factor these. So factors in negative 18 that give me negative 3 are going to be x minus 6 and x plus 3. Set each one equal to 0. Add 6. X equals 6, first answer. And then subtract 3, x equals negative 3. Got to factor the other one. Factors of 18 that give me 11, and that's going to be 9 and 2, and they're both positive. Set each factor equal to 0. Subtract 9. X equals negative 9. X equals negative 2. I got to go back and check now. 4 checks. So let's plug in the 6. So 6 squared plus 4 times 6 in absolute value bars, 7 times 6 plus 18. 36 plus 24, 42 plus 18. This gives me 60. This gives me 60. 60 equals 60. It checks. So x equals 6 is a good answer. And now let's plug in the negative 3. So negative 3 squared plus 4 times negative 3 in bars equals 7 times negative 3 plus 18. 9 plus negative 12, negative 21 plus 18. This gives me negative 3. This gives me negative 3, but I got to absolute value that left side. So this is not equal, so this answer's out. Let's check the negative 9. Negative 9 squared plus 4 times negative 9 in absolute value bars. 7 times negative 9 plus 18. 81 minus 36. 63. 18. 45. Negative 45. 45 is not equal to negative 45, so that answer is out. And now check the negative 2. Negative 2 squared plus 4 times negative 2 equals 7 times negative 2 plus 18. 4 plus negative 8, negative 14 plus 18, negative 4, equals 4. Absolute value of negative 4 is positive 4. This one works. So x equals negative 2 is a good answer. So the two answers that work here are 6 and negative 2. And that is it for section 1.6c.